So I assume you did the Build Your Understanding problems before you watch this video. If not, please stop right now and take a shot at them yourself. I'm going to go through them fairly quickly. So in this first one, on top, we multiply the exponents to get x to the 10. Down below, multiplying, we get x to the 12th. And then the rule for exponents says subtract the one down below from the one on top, and we get x to the negative 2, which lets me know I should have been a little more careful when I was kind of randomly changing the numbers, because we haven't talked yet about what a negative exponent means. So if you just stop there, that's fine. We haven't talked about negative exponents yet. You might remember from an earlier class, though, that this would mean 1 over x squared. And after we talk about negative exponents, then I would want you to give your answer that way. But for right now, if you came out with x to the negative 2, you did everything just fine. Okay, going on to the next one. I've got a fraction raised to a power. So both the numerator and the denominator get the power. In the numerator, we have a product. So each factor gets the power. And by the way, if you want to jump straight to this step, that's fine. You know, if you have products in your numerator and or denominator, you don't need to write out numerator to the power and then each factor to the power. You can just start out having every factor in the numerator to the power and then every factor in the denominator to the power. That's fine. And then please make sure, though, that you remembered all these parentheses. These are all mandatory parentheses. If you omit any of those parentheses, then even if you got the right answer, your step here is not equal to your step there. Okay, so these are all mandatory, so make sure you have those. Anyway, so then you should get 9x to the 12th over z to the 8th. And I just want to quickly give an explanation. We've already talked about needing the parentheses around the negative 3. Why do I need parentheses around my x to the 6th? Well, it's just been agreed by all the math people in the world, and someone decided this at some point in history. I don't know who or when, but it's been decided that if you write this, what is meant is that you're squaring the 6, and 6 squared would be 36. Whereas if you want to say that I've got x to the 6th, and I'm not squaring the 6, but I'm squaring the x to the 6th, then everyone's agreed that you're going to put parentheses around x to the 6th, and that's x to the 12th, which of course is different. And it goes back to that idea I mentioned a little while ago, that exponents can only affect what they're touching. This exponent is touching the 2, so it's only affecting or squaring this. Sorry, this exponent 2 is only touching the 6, so it's only affecting or changing the 6. So it's squaring the 6 to be a 36, whereas this exponent 2 is touching the parentheses, or it's, next to the parentheses, so it's affecting the whole thing in parentheses. So it means x to the 6th times x to the 6th, and there again you get that x to the 12th. Okay, so be careful with using parentheses when you're using these rules. Okay, next example, 3x to the 0, written in two different ways. Again, there's an invisible multiplication there, so this means 3 times 1, because x to the 0 is 1, so you get a 3. In this example, it's parentheses to the 0. Anything to the 0 power is a 1, and that's all there is to it. Last, a couple of cautionary examples to remind you that exponents do not distribute. You should not have done 4 squared plus 1 squared. What you should have done is 4 plus 1 is 5, and then square the 5. And similarly with subtraction, you would not do 4 squared minus 2 squared. You do what's in the parentheses first, and then apply the exponent, and you get a 4, which is different than what you would get if you did 4 squared minus 2 squared.